Okay, hi guys, this is the notes for the intro to trig functions or intro to trig ratios. The three main trig functions that we have are sine, cosine, and tangent. So sine we abbreviate sin, cosine cos, and tangent tan. And so we can call these trig functions, or we can call the ratios trigonometric ratios. Okay, and so sine was opposite over hypotenuse, so the length of the opposite side of the angle. So the sine of an angle is equal to the length of the opposite side divided by the length of the hypotenuse. The cosine of an angle is equal to the length of the adjacent side divided by the length of the hypotenuse. And the tangent of an angle is equal to the length of the opposite side divided by the length of the adjacent side. Okay, and I know you guys have had some exposure to this in Algebra 2. The mnemonic you used to remember that was SOHCAHTOA, right? SOHCAHTOA, so is the SOH, so sine is opposite over hypotenuse, right? The S here is the sine, right? S, and then OH, opposite over hypotenuse. Cosine, right? SOHCAHTOA, so cosine here is going to be adjacent over hypotenuse, so the A over 8, adjacent over hypotenuse. And then TOA was your tangent. So tangent is going to be opposite over adjacent. So we're going to use SOHCAHTOA as a mnemonic to remember the ratios, the trigonometric ratios for each of our three trig functions, sine, cosine, and tangent. Okay, I'm going to break the notes up into three sections here. The first one is, what do we mean by opposite, adjacent, and hypotenuse? The second section will be explaining what a trig function is and what it does. And then the third part will be a couple example problems of how we're going to use it. Okay. So the first part here, we're going to look at a right triangle because we use SOHCAHTOA. We use the trig functions for right triangles. Primarily, for our part, it's going to be almost entirely for right triangles. So we have a right angle here. This tells us we have a right triangle. We know a right triangle has two legs, right? The adjacent sides are legs. And the longest side, the side across from the right angle, is the hypotenuse. Okay? So the hypotenuse never changes. So in this right triangle, it's always going to be AC. AC is always the hypotenuse in this right triangle because it is across from the right angle. To find the opposite and adjacent, we need to look at the two legs and we need to look at the angle in question. So if we're looking at angle theta, okay, we're looking here at angle theta, opposite means across, adjacent means next to. We know that AC is not an option because AC is the hypotenuse. We already know that. So we're just looking at AB and BC. Well, we notice that AB is across, so that's going to be opposite. Opposite means across, so AB is our opposite side. And then next to is the leg that is next to. That's adjacent. So BC then is going to be our adjacent side. Okay. So the opposite side of angle theta here, this angle here, opposite side is AB and the adjacent side is going to be BC. Okay. The hypotenuse always stays the same, but if we change the angle, instead of looking at angle C here, we made, say, angle A, okay, then BC would be opposite, right? The hypotenuse would still be AC, but then BC would become opposite, because that's across from angle A, or alpha, and then AB would be the adjacent side. Okay, so you need to look at the angle in question. The best way to do that is always label the diagram hypotenuse first, and then look what's across from the angle, that's opposite, what's next to the angle, that's adjacent. So if we look at this next question, again, we want to name the hypotenuse first. So the hypotenuse here is going to be PR. That's the side across from the right angle. Right, here's your right angle and your right triangle. So there's your hypotenuse right across from it. Okay. The angle in question here is angle R, so I'm going to circle it, right? Theta here, that's the symbol for the angle, and that represents the measure of angle R. And opposite is across, and then adjacent is going to be next to. Abbreviate adjacent ADJ. So the opposite side is PQ. The adjacent side is RQ. Okay. So that's what we mean by opposite, adjacent, and hypotenuse. Hypotenuse is across from the right angle. Opposite is across from the angle we're talking about, and adjacent is next to the angle we're talking about. Right? So next thing we want to look at is what the trig functions really are and what they do. So we want to start here with sine. We'll just use sine as our example. So the sine of an angle is going to be equal to the length of the opposite side divided by the length of the hypotenuse. So sine of theta, right? So katoa, so SOH. So sine is opposite over hypotenuse. So the length of the opposite side divided by the length of the hypotenuse. Okay. And at the bottom here, this is what we want to talk about. It says it's a function that maps the measure of the angle measure, to the ratio of the opposite side and the hypotenuse. So I want to look at the next slide to demonstrate that. Okay. So before, though, we start here, I want to kind of write a side note up here about what a function is. So an example of a function could be something like f of x, let's say, equals x plus 3. Okay. So a function has an input and an output. So you can input x values, right? And your output is going to be values for f of x. Okay, so if we input a 1 in for x, you then get 1 plus 3, that's going to give you an output of 4. You input a 2 plus 3, you're going to get an output of 5, right? So we're mapping the x value to f of x. So the input is 1, you get 4. The input is 2, you get 5. The input is 3, you're going to end up with 6. Okay, so keep in mind that's what we're talking about when we're talking about functions. You have an input and an output. Okay, so the sine function, there's going to be an input, and that's going to be the angle measure. The measure of the angle is the input into the function, and the output is a ratio. All right, so I have 3 similar triangles here. So again, they're all 3 of these. We can see 3 triangles, I hope. We have the small one here. Okay, if I want to redraw, let me try to redraw some of them here. Here we have the small one. So this is going to be 4, 3, and 5. All right, if we change colors now, we can draw one of the other ones. Let's draw the middle-sized one. Okay. So the base on this one is going to be 4 plus 4, which is 8. The height is going to be 6, and the hypotenuse here is going to be 5 plus 5 is going to be 10. Okay, and then this is going to be 36.87. And again, for this one, this was also 36.87. Right, and then now let's draw the big one. Okay, so then we have our big one. Okay, so the base of the big one is 4 plus 4 plus 4, which is 12. The height is going to be 9. And the hypotenuse is 5 plus 5 plus 5, which is 15. Okay, and again, our angle here is 36.87. Okay, so the sine of the angle, so let's take the sine of 36.87 36.87. Okay, that's the input into our function, because remember, this is a function. So our input, it's just like on the f of x here. We're inputting a number. In this case, we're inputting 36.87 into our function, and the output is going to be the ratio of the opposite, the length of the opposite side over the hypotenuse. Okay, so move this out of the way. Okay, so you can pick any one of these triangles. So if we look at the bottom here, right, opposite, what's opposite of this angle here? It's going to be the 3 over, so 3, and then the hypotenuse is 5. Okay, we could also use the other triangles. Opposite is 6, hypotenuse is 10, or we could use the last one here. Opposite is 9, hypotenuse is 15. Okay. So the idea here, it doesn't matter what right triangle you have. If you have a right triangle and one of the angles is 36.87, we know what the ratio of the opposite over adjacent side is going to be. We know it's going to be equal to 0.6, right? 3 divided by 5 is 0.6. 6 divided by 10 is 0.6. 9 divided by 15 is 0.6. So the whole idea of trig functions is if you have an angle, you can input it into one of the functions and it gives you what the ratio is going to be. Okay, so sine will give you the ratio of opposite over hypotenuse, cosine will give you the ratio of adjacent over hypotenuse, and tangent will give you the ratio of opposite over adjacent. Okay, so it's a function, you're inputting an angle and outputting a ratio. Okay, let's go to the next page. I have a link here. I will post this, and you guys can check that out if you're interested. But then the last thing I want to talk about are a couple of examples here. Okay, so we can actually go ahead and use it. So these are right triangles. So angle B should be a right angle, and angle E should be a right angle. First off, let's look at angle A. So let's circle angle A. Okay, I would always label your hypotenuse first. That's going to be AC, right, across from the right angle is your hypotenuse. So there's your hypotenuse. All right, and then opposite is across from the angle. So we're going to look at A first. Okay, our opposite is across. So this is going to be the opposite side. Okay, and then adjacent is next to. So here's your adjacent side. Now we can fill in our ratios. So SOHCAHTOA okay, so sine is going to be opposite over hypotenuse. So sine of A is going to be opposite side is 4. And the hypotenuse is going to be 5, opposite over hypotenuse. So 4 over 5. Cosine of A, cosine here is going to be adjacent over hypotenuse. So the adjacent side is 3. And the hypotenuse is 5. And then tangent of A, so tangent, that's your TOA part, T-O-A. Tangent is going to be opposite over adjacent. So opposite side is 4, and your adjacent side is 3. Okay? And then to find the sine, cosine, and tangent for C, we want to erase our diagram, right? Because it changes when you change the angle. Okay, and now we're looking at C. Okay, the hypotenuse stays the same. That's all. We're never going to change. But now the 3 becomes the opposite side, and the 4 becomes the adjacent side. Because the 3 is opposite, and the 4 is next to, so it's adjacent. Okay, so then sine of C right, is going to be sine is opposite over hypotenuse. So opposite side is 3, hypotenuse is 5, so 3 over 5. Cosine of c, so cosine is adjacent over hypotenuse. So the adjacent side is 4, the hypotenuse is 5, so 4 over 5. And then tangent is opposite over adjacent. So the opposite side is 3, and your adjacent side is 4. Okay? And notice how the sine of A is equal to the cosine of C, and how the cosine of A is equal to the sine of C. Notice how these are equal, because the sine and cosine of complementary angles are going to be the same. Okay, our other example, let's look at angle D. Okay, sine is opposite over hypotenuse. So katoa, right? Sine is opposite over hypotenuse. Our hypotenuse is 25, right? Across from the right angle, so that's always the hypotenuse. And then we have two other sides we want to look at. So across is opposite. And then adjacent is next to. Okay, so sine is opposite over hypotenuse, so katoa, SOH, so sine is opposite over hypotenuse, so opposite is 24, hypotenuse is 25, so 24 over 25. Okay. Cosine of D, cosine is adjacent over hypotenuse, so katoa, so CAH, so that's adjacent over hypotenuse, so adjacent is 7, hypotenuse is 25. And then tangent is opposite over adjacent, so opposite side is 24, adjacent side is 7, so that's going to be 24 over 7. Okay. And again, for F, we want to change. So again, the hypotenuse stays the same, but the adjacent and opposite sides are going to flip. So let's circle our side F. Okay. Across from it is opposite. So this becomes the opposite side, the 7. And then this becomes the, what's happened? This becomes your adjacent. Okay. So opposite side is 7, adjacent side is 24. I'm sorry. Sine is opposite over hypotenuse. So opposite is 7. Hypotenuse is 25. Okay. Cosine of F, right? That's going to be adjacent over hypotenuse. So adjacent is 24. Hypotenuse is 25. And then tangent of F is TOA. So opposite over adjacent. So that's going to be 7 over 24. Okay. And that's the notes. You also have some optional Khan Academy videos that can help. They do a really good job of going over example problems. So if you didn't understand this, you can check those out.